So here are some other terms that we need to know, which we use these terms for the profit maximization. The first one is marginal product of input. Similar concept we had for the consumer theory, which was marginal utility. But here we have marginal product. If you remember, in the marginal utility, the marginal utility of x was equal to the partial derivative of utility function with respect to x. But here, the marginal product of an input also is equal to the partial derivative of production function with respect to that input. For example, if we have this production function, which is y equal to a function of labor and capital, then if we find out the marginal product of labor is equal to the partial derivative of this function with respect to L, and the marginal product of capital is equal to the partial derivative of this production function with respect to capital. The other things that we need to know is average product of input. Average product of labor is equal to, in that case, the total output divided by the total number of labor that we use. And also the average product of capital is equal to the total output, which is f of Lk, divided by the total number of capital. Similar concept that we have for consumer theory, which was the marginal rate of substitution. But for producer theory, we have marginal rate of technical substitution between input x1 and x2, or xi and xj. This xi and xj can be labor and capital. So here, in the utility maximization, or in the consumer theory, the marginal rate of substitution was equal to the marginal utility of x divided by the marginal utility of y. For example, here, then the marginal rate of technical substitution is equal to the marginal product of xj divided by the marginal product of xi. Xj can be labor. The marginal product of labor divided by the marginal product of capital. If someone asks us to find out the marginal rate of technical substitution of labor for capital, which we can write down this way: marginal rate of technical substitution of L for K is equal to the change in capital by the change in labor is equal to the marginal product of labor divided by the marginal product of capital with some negative sign. Because when you increase labor, you should decrease capital. That's why it should have negative sign. In this formula, only the marginal utility changed to the marginal product. The other thing is exactly the same. Why it's similar? Because as you know, the isoquant and also the indifference curve, both of them, they have like some kind of identical shape. Why they have some identical shape? Because most of the case, the utility function that we use, we have some identical shape for the production function. Like we have u x1 to the power of alpha, x2 to the power of 1 minus alpha as a utility function, and we have y as a production function, L to the power of alpha, k to the power of 1 minus alpha. So when we have like similar functions, so they have similar shape, the isoquant is similar. So in the case of production, the marginal rate of technical substitution, if this is our isoquant, then the marginal rate of technical substitution is equal to the slope of this isoquant. As we had that the marginal rate of substitution was the slope of indifference curve. Here this is labor and this is capital. So the slope of this one is equal to the marginal rate of technical substitution. And if we use this one as an indifference curve, so the slope is equal to marginal rate of substitution. So that's why they have similar formula, but here is marginal product, but in utility it was marginal utility. So another concept we have is the elasticity of substitution. And the marginal rate of technical substitution, we show the rate of substitutability. Our marginal rate of technical substitution shows the slope of isoquant. But here, the elasticity of substitution, which is like a measure of the percentage change, and the capital labor ratio, or in input ratio, we can say, just simply input ratio, from a 1% change in the marginal rate of technical substitution. What it measures? This measure indicates how easy it is for the firm to substitute one input for another input along an isoquant. So it shows that either it's easy to substitute or it's difficult. As I said, this measure indicates how easy it is for the firm to substitute one input for another. So this is the general formula: percentage change in capital labor ratio divided by the percentage change in marginal rate of technical substitution, and is equal to the D ln of input ratio divided by the D ln of marginal rate of technical substitution. It means if we have this one, if we take the derivative with respect to the ln of marginal rate of technical substitution, we will have the elasticity of substitution. And this one we can write down by this one, the change in capital labor divided by the capital labor, then the change in marginal rate of technical substitution divided by marginal rate of technical substitution. And when we have some production function, we need to find out the marginal rate of technical substitution first, then we need to find out the capital labor ratio second, and then we need to take the derivative of, then we need to transform to logarithmic function. When we change it to logarithm function, that we can easily find out the elasticity of substitution. I think I already uploaded some videos related to this one, how to calculate. Then I will just transfer the link for that. Then we know how to calculate this one for the different production function, because if we calculate now, it will take a lot of time.